Hey, thanks, Greg, and thanks everybody for the opportunity to talk here today. And I just wanted to extend my congrats to Ian as well. Very great talk there, and I hope to follow that up with some maybe nudging ourselves in a direction aligned with what you were bringing up about collaboration. So. I also wanted to note, anytime I see a picture of Mike Wargo, I've got to comment on just what a tremendous community member he was. He certainly helped me and many of my peers out early in our careers, moving along. And in fact, I do like to point out that just over my shoulder up here is a little crater. I like this picture. I've got Wargo crater right here. On my wall. I do a good bit of work for our Office of Communications, and so I had to put some pictures on the background. And so I like to think that Mike's always sitting on my shoulder as I go through this. The position I have, Chief Exploration Scientist, he was the first Chief Exploration Scientist that we had at NASA. So always great to see that, and congratulations again, Ian, on your award. So I'm here today talking a little bit about Artemis and how we hope to achieve science, and doing that in a collaborative manner, working in a multinational, multi-agency way. So I'm going to talk a little bit about how we are structuring ourselves inside NASA to meet the mission we have, but also how we're structuring ourselves in a way to collaborate broadly in a multinational, in a worldwide sense, because I agree with Ian's comments about going forward, right? This is a humankind effort that we're doing now. This is not a single country or a single agency or a single institution. So that was a great presentation, Ian, and I loved hearing those words. Next slide, please. So with that said, we do have funding that is somewhat divided nationally, multinationally. And so I do want to start out by saying how we are motivated and driven inside NASA. So this is just a series of the documents that help set the framework for what we, NASA, are challenged to go accomplish by the United States government. And if you look, here's a series of documents. I'm sure every agency and every government has similar documentation. But what we in NASA have been challenged to do is lead deep space exploration. And in those priorities, we just have a quote, one of the quotes here that we're challenged to do, leading human and robotic space exploration, to land the first woman and person of color on the moon, advance a robust cislunar ecosystem, continue to leverage human presence in low Earth orbit, to enable people to live and work safely in space. And in general, prepare for future missions to Mars and beyond. Our Pam Melroy, who helps lead our agency, has frequently been saying, we're working on building a blueprint, how to develop a blueprint for space exploration. I really like that. It's not so much anchored in a single destination. It's learning how to live and operate in space so that we can go do all the amazing things that not only NASA wants to do, but work collaboratively to meet everyone's objectives. Next slide, please. So with this challenge that we've been given at NASA, we've been sort of reorganizing ourselves and starting to rethink, how do you develop an architecture to meet this kind of a challenge? And so we're kind of starting with the why are we going? And so from our government's perspective, from the United States perspective, we've broken that down into basically 3 pillars of why we're exploring. We refer to those as our science, our inspiration, and our national posture. And so each one of these has some unique attributes, but there's a good bit of overlap. And a large part of that overlap comes together in working in partnership, not only within our country, but multinational collaboration in order to go do these things. So these are the why reasons we're going. And as Ian was pointing out, science and exploration, Science is a big piece of this, going to understand, the history of us, basically. We have had a series of meetings over the last 2 weeks to discuss what I'm about to present to you, how we're developing our Moon to Mars architecture. One of the things I'd like to say, I love the last photograph that Ian showed, looking back from Orion at the Earth and the Moon. I like to point out that there's a reason that no matter how far away we go with our spacecraft, we typically always still take a picture of the Earth. Whether you're looking back at the Earth through the rings of Saturn from Cassini, or if you're on the solar tips of the Orion, and when Apollo first gazed back at the Earth rising above the Moon in Apollo 8, because when we leave the Earth, we're actually leaving to learn about ourselves. You can subdivide science into many disciplines and very specific focused objectives and goals, but ultimately we're trying to understand ourselves and our place in this universe, in this galaxy, in this solar system. And those questions can't be answered by staying here on Earth. The very processes that enable life to exist here are the same processes that have altered some of that evidence, or maybe even erased it entirely. Plate tectonics and atmosphere. You also can't only go to Mars to answer those questions. Some of those similar processes exist there. And so I like to talk about the fact that we're really talking about an Earth, Moon, Mars system that we're trying to explore, which may point to other destinations as well. So it brings me back to this point about we're really developing a blueprint for how to live in space, to work collaboratively, to go answer some of these big questions and learn about the history of humankind. Next slide, please. So to meet these objectives, to meet the goals that we're setting forward, we're kind of starting to rethink the way we build our architectures. In the past, at least within NASA, we've done what we're kind of calling now architecting from the left. And if you think about looking at a slide, you set things up on the left side of the slide and you start moving to the right. And often we would build something and then try to decide how we needed to use it to go meet objectives. Well, now we're trying to start with why. The why. Why are we exploring? So again, from our government's perspective, we've broken that down into science, inspiration, and national posture. But every government probably has their own desires, their own explanations of what the why are. And so we're in a process now of starting to collaborate, to work together to understand the broader spectrum of why. But this is the starting point that we carry for NASA. But as you start to answer some of the other traditional big questions, who, what, when, where, how, they're all a part of the story of pulling together an architecture, developing an architecture to go meet those objectives. Now, depending on where you start with these questions, you could develop a different architecture. For instance, Apollo, that started with a question about when. They were told very specifically when they were going to go, and they had to develop an architecture that met the when and then filled in the other answers. So we're trying to be a little more broad now and start to look at these questions together and really start from why. So what kind of capabilities do we need in order to answer these why questions? Where should we put our systems that we develop? How will we get there and how will we return? When will we do this? Who does this approach include? And this gets to the point I was making about the collaborative nature of what we're trying to do here. NASA knows that we can't do this alone, because when we do this alone, it kind of has an end date. We saw that from Apollo. We've seen that from other programs. What we are trying to envision is something that carries forward in hopes of reaching some form of sustainability in whatever way sustainable is defined by our partners as well as ourselves. Next slide, please. So over the last year, almost 2 years, really, when we started getting into this, we went through a process of trying to define our key stakeholder objectives. And this is part of why we are now referring to this as starting to architect from the right. So I talked about architecting from the left. Well, now what we're trying to do is say, what are the things we want to accomplish? How can we break those down into understanding what is needed to meet those goals and objectives. And from that, we can start to build an architecture that's informed by traceability to the objectives. So within NASA, we identified 4 broad sets of objectives. Those are science objectives, transportation and habitation, lunar and Mars infrastructure, as well as operations. And those operations could include in space or on the surface of a destination. We developed these initially internally. We opened up the conversation within NASA and then began that conversation with other agencies within our own government, with our industry and our academic partners. And then we engaged internationally as well. So last year in 2022, we held a series of meetings in London, as well as in Houston, Texas, here in the States, to engage broadly and ask about these objectives. So the objective set that we have includes input basically globally, depending on who participated when we opened those activities up. Over the last year, we've been taking those objectives and trying to break them down into what we call characteristics and functions. In essence, if I want to accomplish a certain objective, what are the things I actually need to have in order to meet those objectives? Those functions and capabilities are how we then build an architecture, how we make decisions about what elements we need to build. And it could be there are many more elements than we actually have an ability and a budget to develop ourselves. And that's what's critical about developing this architecture in this way. We can identify what's needed, and then together we can start working on how we address those. So we've developed a process we call the Architecture Concept Review, or ACR. This is a yearly review process for NASA that will include community interaction. In fact, just last week, we were again in London interacting. We had 17 space agencies or nations present at the meeting, representing, again, their agency and or country, and their perspective about how this review process works. And then this week, we held a similar workshop here in Washington, D.C., interacting with our industry partners and academic partners within the United States. Next slide, please. So the Architecture Concept Review is a phrase that I'm hoping everyone will start to become familiar with. This ACR, if you will, the acronym, is driven to produce public documents so that the decision-making process and the outcomes are known to the community. We've been criticized in the past, NASA's been criticized in the past for kind of working behind closed doors, and we're trying to get away from that. There are certainly some things that will do internally, but at the same time, as much as we can document this in a public manner to drive discussion in that yearly cycle, so that when we have our next workshops next summer, that information will be public and we can have discussions that are informed on the products that come out of the review we're currently in. The document that we're generating and putting out in public is called the Architecture Definition Document, here at the very top of this slide, or referred to as the ADD. So this is the document that will detail basically a snapshot of our architecture planning on a yearly cadence. So our review cycle, that Architecture Concept Review, gives us a chance to study the input that we receive from the workshops, as well as set up a series of tasks to explore the trades to help us go and meet the objectives that we have outlined. The Moon to Mars Architecture Summary is sort of a shorter version of that, so you can start there and get just the general perspective of what we're talking about, or you can dig into much more detail with the ADD itself, which right now is about 150 pages. Off to the right here, we also started developing a series of white papers, again, also public documents. We released these about a month ago, our first set. The white papers are meant to be short, 4 to 6 pages each. And the purpose that they serve is to address a specific topic area. So for instance, we've been finding that when we go out in public to speak, we're often asked the same questions at every venue that we go to. So the white papers are designed to provide feedback to the community that we're engaging with as to what it is we're actually doing. So for instance, I helped author with my colleague Noah Petro a white paper that explains why we're going to the South Polar region with Artemis. But we have additional papers. Another favorite is why the near rectilinear halo orbit for our gateway. That's a topic we get asked about frequently. Now we have a public document that tries to clearly explain that. And so we talk about all of these documents in the workshops that we held last week in London and then this week in DC as part of that annual review cycle at ACR. Next slide, please. So I want to put this in here. There's a QR code that takes you to the location where all of this documentation is currently held. The workshops that we just ran gave us a lot of feedback. We have a number of additional white papers now in consideration. We were specifically asking for feedback from the community about the architecture definition document. So I would encourage you all to take a look at that documentation. The QR code will get you to the website. You can also go to the web link that we have down there. If you just type that in, nasa.gov/Moon to Mars architecture. But this is the starting point for basically understanding where we are in our architecture planning. Oftentimes when we don't communicate enough, it can be easy to think that we're much farther along than we are, or that we've made decisions that don't make very much sense. And so we're trying to get all of that information out in the public so that you can, learn about it. Doesn't mean we'll always agree on all of it, but we're trying to be as public facing as we can about this. The key here to our workshops that we're running is that we understand from our partners what their goals and objectives are as well. So I've talked a little bit about what NASA is trying to accomplish, but we know that that's not the complete set of what humankind wants to do as we learn how to live and explore in space. So we need to understand that. The whole concept review, the ACR, is focused on looking at the broad set of stakeholder objectives that we have amongst our partners and trying to make informed decisions about what the next step should be that helps advance us on a front that contributes to as many stakeholder objectives as we can. And so that's kind of where we are in this process right now. Next slide, please. So go back to the original slide, my first slide, talking about the 3 pillars of the why we go. And now I want to focus a little more on the science. So I wanted to give that update that's almost hot off the presses as we have just come out of those workshops, the international and our industry workshops. So science is one of those 3 major pillars. And so I do want to talk a little bit about how the science traces into this. So from our Science Mission Directorate here in NASA, one of the things that we're trying to do is be very clear about traceability of the documentation. And so our science colleagues have brought forward, the documents that kind of drive our Science Mission Directorate. And they largely are driven by research priorities from the Decadal survey. So the national academies conduct a decadal survey for each science division that we have. And so that basically helps set the priorities for what NASA should be trying to accomplish over the next decade. And they go through a review cycle halfway through. So it's really about every 5 years, they kind of get a fresh update to that. These are the guiding documents that we look to and trace to. There are also, within planetary science, if we are starting to focus more on the moon, a series of community documents that basically feed into these decadal surveys, but they also stand alone on their own. So we have those listed at the bottom there as well, just as reference. The document on the bottom right, the Artemis III Science Definition Team report, was one of the first documents that really tried to begin with some of the assumptions that we had for Artemis at the time. So that's almost 3 years old now, so it's not brand new. But starting to think about how do we go about exploring in the South Polar region with some of the assumptions that Artemis has. Next slide, please. Now, in addition to the science that we showed on the prior slide, we also have research on basically how humans survive in space. So we kind of boil that down into what we call, in NASA, we call the 5 hazards of human spaceflight. Doesn't mean there aren't more than 5 hazards, there certainly are, but these are the big ones that we focus a lot of our attention on to basically, again, help realize how to develop a blueprint that would enable humankind to spend more time in space. So we largely bin those into space radiation, working in isolation and confinement, operating at ever increasing distances from the Earth, dealing with gravity or lack thereof. And really what we're talking about there is gravity changes. If we want to go to Mars, for instance, that's a long trip in an environment that does not have gravity for the astronauts. So when they arrive at Mars, we have a lot of questions about how quickly can they begin to do work in a dependable way. So do we need to develop an architecture that has them landing on the surface and pushing buttons and pulling levers right away? Or do they really need a few days in order to be at a state where they can confidently do that work? These are the types of things that we have to learn. We are learning it in low Earth orbit. We'll learn about it as we go to the moon and spend more and more time there. And at some point, we'll have the confidence that we can take that longer trip to a destination like Mars. Also, just operating in hostile closed environments. So that gets a little bit more kind of like microbial aspects and making sure how do we keep an environment like that safe and healthy for our astronauts when it's this closed environment for such a long period of time. Next slide, please. So you probably, if you're in a lunar symposium, noticed that last year we were able to successfully fly our Artemis I mission. The mission went very well. Tested our Space Launch System rocket as well as our Orion crew capsule. That flight gave us a tremendous amount of data that is propelling us forward. And I like to really say that, before this, we were talking about, the Artemis generation. The young people today will be the Artemis generation. Well, we are all now the Artemis generation. Artemis I is behind us. It was successful, and it's put us in a position to prepare to fly all the Artemis missions that will follow. Next slide, please. So right now, we're actually looking at some of the data that came back from that. So even though there were no crew, we did have a tremendous amount of science that was conducted. We had a whole set of CubeSats that rode along with the SLS, and they have been going through various amounts of data. Not all of them were 100% successful, but that was sort of expected going into the missions. But they all have been learning about how do we take advantage of opportunities, for instance, being able to carry secondary payloads like this on any launch that we have within Artemis. So together, we have learned a great amount about how do we take advantage of those opportunities from launches. Additionally, we had payloads inside the Orion. Those are on the left side of this slide. And across this board, I do want to point out the little stars note places where we have international participation. So the science right from the first Artemis mission has had a good bit of international integration built into it. On the left side, one of the things I really like is that we were learning about that deep space environment where astronauts are going to be flying. We collected a tremendous amount of data about the radiation environment. We have collected information about potentially how to shield ourselves from that, what kind of forces the astronauts are going to feel coming back to the Earth with Munikin Campos, the commander of the spacecraft. So there was a lot of work that went into Artemis I, even though it was really focused on that first flight of the SLS and Orion in an integrated manner. We did gather a lot of data to help us move forward. Next slide, please. Again, so Artemis I, wonderful to have that kind of in the rearview mirror. We're still working through that data, but we're also full speed ahead on planning for Artemis II. So Artemis II in some ways will be somewhat repetitive of the flight of Artemis I, but now we will have our astronauts on board. Earlier this year, we named the 4 astronauts who will participate, including an international astronaut from Canada. So again, trying to find ways to take this kind of slow approach. Artemis I, Artemis II, gaining the confidence that we've got a system that can carry our astronauts, and now we'll go fly with them on Artemis II. That will put us in a position to land on the surface of the moon with Artemis III. Next slide, please. So Artemis III will be a human landing in the south polar region of the moon. So again, learning what we've learned from test flights of the Orion, launches with the SLS. We will now be in a position to use our human landing system for this mission provided by SpaceX. Their Starship spacecraft will dock with the Orion, which carries our astronauts from Earth out to a lunar orbit. And from there, they'll then move down to the surface of the moon, again in the south polar region. Next slide, please. Now, one thing I do want to touch on briefly is the environment of the moon that we're dealing with. So one thing I've talked a good bit about lately is the lighting that we'll deal with. So oftentimes when I talk with folks, I know if in their brain there's a picture of an Apollo event. Apollo took full advantage of the information that we knew about the moon. In the equatorial region, really between 85 and 85, north and south latitude, almost every location experiences a 50-50 ratio of light and dark. And that ratio is split up in a cycle where 14 Earth days of light are followed by 14 Earth days of darkness. And that's one lunar day, roughly about one Earth month. We understood that. Apollo took full advantage of it, landed in the early lunar morning, and then we knew that we had, anywhere between 7-8 days to 10 days of continuous light within which we could operate. So those missions took full advantage, again, of that knowledge that we had. One thing I do like to point out, we talk a lot about, or NASA talks a lot about, we're going to do science. We're going out there and exploring to do science. I think it's also very important to note that the science we already know, what we've learned from our scientific exploration of the moon, that knowledge is really, I like to refer to it as the backbone around which we wrap our architecture. That knowledge helps us determine how to build a system. What are the environmental conditions that we have to prepare for? This is a great example. Apollo had knowledge of the moon and took full advantage of it. Next slide, please. So this is just an example on the surface. And again, when I say having an Apollo picture in your mind, it might be something like this. Two things I want to point out here are that in this picture, you're in complete sunlight. If you drove 50 kilometers away from here, you would still be in complete sunlight, exactly like this. Also, note the antenna is just pointing straight up almost, because the Earth is there. If you're on the Earth-facing side of the moon, near the equator, the Earth is above your head. And it's pretty much visible all the time. But it's not like that in the polar region. And I hear people say often that landing in the poles is hard. It's more difficult. And I like to challenge that. I think difficult might not be the right word. It might be different. I like to say that it will be different landing in the polar region and operating in the polar region. The environmental conditions are no less predictable. We can predict them, but they are different than what we are familiar with from the equatorial region. Next slide, please. So this is a video just showing, and many of you probably have seen it or use it, maybe even helped put it together for us. But it really does drive home. If you think about the video I showed of the Apollo landing sites in contrast to this, what you're seeing here are more like sweeping shadows and sweeping patches of light. The ratio that you experience between light and dark over an entire year is not necessarily a ratio of a 50-50 split. It could be 80 to 90% sunlight in a year, ranging entire darkness for a whole year, permanent shadow. And what makes it a little more difficult to deal with, again, maybe not difficult, but just different, is that ratio can change. It can change across the surface. So if you drive 5 kilometers, the ratio of sunlight to darkness is going to change. And again, it could range from significant amount of light throughout a year to complete darkness. And so this is what we have to understand. But again, this is why we sent a spacecraft like the Lunar Reconnaissance Orbiter to begin mapping this for us back in 2009. It's put us in a position to be able to challenge ourselves in this way. But you can take advantage of this as well, just like Apollo took advantage of the conditions. The sunlight is something that you can take advantage of. Next slide, please. If you know where places are that experience greater than average amounts of sunlight, then you don't have to go through some of the thermal changes, or at least as frequently through the thermal changes. You might not need batteries the same size. This is why I challenge the term difficult or hard. To me, if we want a sustainable presence, the equatorial regions are actually quite difficult, because you must survive 14 Earth days of continuous darkness multiple times a year. Whereas in a location like this, if you pick the right spot, you might have to tolerate shorter stretches of darkness and only once or twice throughout a full calendar year. So this is just an example of some of the locations. The South Pole is actually in this image along the Shackleton Rim, kind of that arc of light on the right side. A region we refer to as the Ridge or Connecting Ridge, it goes by a number of different names in the community, is off there to the left. And so you can see the contrast in the amount of light that you might experience at this given moment. But that changes throughout the year. Now, inside Shackleton Crater is the location of permanent darkness, areas that never see sunlight. Now, those are areas where the environmental conditions would potentially preserve volatiles had volatiles ever entered into that area. We do have data suggesting the volatiles are present in the polar regions in some of these locations. And so that's some of the information we need to understand is what is the state of those volatiles? Can we get to those? What do we need to do to clean them up into a way that we can use them, or to extract the science knowledge we would like from them? So I think this goes back to the point Ian made and just before I started about, exploration and science. They really are a part of the same effort. We would like to understand the science of the volatiles inside those dark regions, but first we sort of have to understand how to even get to them. What are the right pieces of hardware we need to get to those volatiles to extract that information? Next slide, please. And so I'm going to end with this slide here. This is another LRO oblique view of the Malapert Mountain region of the moon. And again, I just really like to show as many pieces of data as I can to highlight the contrasting light and dark in the polar region. And I just will say one last time, in hopes everybody will also help repeat this, that it's not that it's necessarily more difficult, it's just different. And this is the environment that we will be operating within in order to take advantage of the light for thermal properties and the lack of light for the types of science that it might preserve for us to access. So with that, Greg, I'm done. I'm happy to answer any questions. And if you maybe could just help me get those questions so I can hear them properly through the computer, that would be helpful.
You bet. Thank you, Jake. Okay, I know it's late here, but let's take time since Jake has it for a few questions. And is there someone who could run the mic? Yeah. Okay. Great. Thank you. Yeah. So, do we have any questions? Yes. Thank you. If you could please identify yourself, if you wouldn't mind.
Hi, Jake. This is Karen Vanderbogert from the University of Münster. This is just a question that kind of takes off from some of the previous presentations that we had in terms of the prospect landing site selection. I wondered if maybe you're the right person to ask why that CLIPS delivery is being excluded from other Artemis landing sites, or is that situation going to change when you down select? That prospect could actually go to one of those Artemis landing sites?
Yeah, so thanks for the question. It's good to hear from you. I can't see you, but I'll wave anyway. Maybe you can see me waving to you. Unfortunately, I'm not the right person to answer that question for you. Ian noted about not having directorates that deal with different things, but unfortunately we do. And that's mostly the CLIPS is in our Science Mission Directorate. So we have worked with them to let them know the regions that we have under consideration, but I do not have an answer to how that determination might evolve as we move forward with Artemis. But I know that that question is one that we are thinking about and that is being thought about within CLIP. So the one thing I do often say to everybody when I'm out here talking in public is I often plead for patience. You know, we've never done this before, and we're trying to learn how to collaboratively conduct robotic exploration with landers like CLIPS that are commercial lunar payload services that are being handled by industry partners at the same time as we're trying to figure out where to land human beings, while we also have, you know, maybe vehicles like the Viper rover that's down there trying to study volatiles. So the one thing I would just say is, you know, the way we do things at the very moment is likely to evolve. And just, I know that's not the greatest answer in the world. I never tell everybody that I'm going to give you great answers, but I'll show up and I'll tell you what I can and what I know. So just please be patient with us as we work through how to do this, right? We want to be very cautious at the beginning and then learn how to adapt and evolve so that we can try to meet the objectives broadly across the community.
Well, maybe then just one that's maybe a little easier, or you can give us a better ballpark for is what's the timeline that you're looking at down selecting from those existing many landing site opportunities for Artemis?
Yeah, so so everybody's on the same page, last fall we identified 13 regions. Now 13 regions include many potential specific sites where we could land a lander. And we did that before we had fully brought on board SpaceX, who won the contract for that lander. So now we've been working with SpaceX, you know, trying to understand the actual capabilities of the vehicle. So we're in the midst of that process, working with them, understanding how their expected vehicle performance, so that we can begin to narrow that down. We are working through that. You know, I can't promise you exactly when that's going to be, but we are making progress. And I would hope that we'll be to the point of being able to discuss that, you know, sometime later this year, in the next several months to later this year.
Great, thanks. Jake, we have a question from the online chat from Jayden Mehta. Hi, this is Jayden from Moon Monday. How do you imagine countries who have signed the Artemis Accords could band together in various ways to do lunar, oh, it just lost it, to do lunar and science and exploration outreach, I believe was the question. Okay.
Yeah, that's a really good question. And in part, the reason we're putting the accords together is to try to make sure that we're not just focusing on big space agencies that can, you know, it's great that we can partner with other big space agencies and look at building big elements and really the big pieces of that architecture. But again, that we want to include and be as inclusive as we can. So what I love about the accords is that those are countries, and many of them don't have extensive even experience, but even budgets today that would enable that kind of a contribution. Nonetheless, they still are telling us what they hope to achieve, what their goals are, what their motives are for being interested in lunar exploration. And I think that as they begin to sit at the table and have the conversations with us, what we see is that they're starting to work within their own countries to think about, well, here's how we need to train and educate folks so that we can participate. Here's how we need to connect with our communities so that they understand where we're going. So just in being a part of the conversation, this is my opinion, but I believe I see that they are now starting to have more engagement inside their own countries and in their own areas of influence about what they're seeing, what they're learning. So for instance, we were just over in London, we had a number of countries there that were talking with us, and a few folks came up to me and just said, you know, when we presented the white papers, they said, I have been asked that question so many times and I never had an answer to give. So at the very least, they are now able to take that knowledge back and share it with their communities who they are telling us are asking them the same questions. So, you know, slow starts and baby steps to get going, but, you know, these are, again, pleading patience always. You know, these are the steps we have to take to make sure that we have a good, solid base that we can continue to build from.
Fabulous. Thanks. Next questions for
Yeah.
Bernard.
I'm Bernard Frank, so I'm from Urban Mars, but also Moon Village Association. And on this point, now that we are all part of Artemis generation, even if we didn't sign the Artemis agreements, I think that we should all work for it. And I would like to advertise that 2 years ago, we proposed to the United Nations to celebrate International Moon Day on 20th of July. And so all countries are going to celebrate it. So it could be also an opportunity to expand as Artemis generation, also to unleash, so there will be funding for each country because they signed at the UN, but we could also think of specific activities that our community could organize to support this International Moon Day. So do you see anything special we could do as at NASA or as a survey to support International Moon Day?
Yeah, well, Greg can answer too on behalf of Survey, but you know, I think that effort and many others that I've seen are great examples of how just starting the conversation leads to great ideas like this. And I think those are great ideas. And NASA helped start something we called International Observe the Moon Night, where we just try to have everybody take a break and just look at the moon, right? Because sometimes in today's culture, you almost forget about it up there if you're not people like us who like stop traffic because we're staring at the moon. But I think what you're talking about is a great idea. And the more we help initiate those conversations and the collaboration, the more we're seeing that kind of opportunities, ideas being created. So I'm really glad that you brought that up. And you know, I can't speak on behalf of NASA and how we participate, but I can say that I know as a lunar scientist, as someone who's interested in the moon, I'm really grateful that event has been created.
Yeah, I would agree, Bernard. And yes, let's talk about participating in that. And I do want to note that our institute was the one that put international and international Observe the Moon Night. And I believe that the original event was Brian Day's idea, who's sitting right here. And so bottom line, yes, I said it before at the introduction, we consider our international partners our most valuable assets. We want to do this together, and so let's talk about it. So and I want to say now Mahesh has told me that we need to be out of the building in just over 20 minutes. So Jake, I want to say thank you very much again. A fabulous talk, and really appreciate you taking the time to join us. Thank you.
Thank you, everybody.